All right, so welcome to today's session, A Taste of Scratch and Scratch Junior. We added a QR code and a short link if ever you want to access these slides as a resource for later on. Also, the last slide has our contact information and some useful links. So if ever you wanted the link to the PowerPoint, we'll add that short link to the chat as well. The agenda and intentions, it's about a 1-hour hands-on session. We're going to divide it into 3 parts. The first part, we're going to look at why code. We'll demystify coding. We planned a Scratch along, so a code along with Scratch and Scratch Junior. The goal is really to have a hands-on experience playing with block programming, because oftentimes people could describe what Scratch is or Scratch Junior, walk you through it, but it's never the same as when you experience it and when you try creating a fun, simple Scratch project. And we'll use the last minutes to share some projects that you've done. Also, if ever you have any comments or questions, we'll address them then.
Oh, that's mine. Thank you for that. So there's just a reminder not to forget the digital competency framework. So obviously what we're scratching today in Scratch Junior, you're going to be developing tech skills. Number 2, the number 10 is solving diverse problems. Number 12, the innovation and creativity, which is key, and many other dimensions, right? It's not just these. The problem solving piece, it's not just debugging the code, right? We're not just going to look at the problems with the blocks and try and fix them. We're thinking about real life problem solving related to the environment and health on a global scale, where there needs to be many possible solutions. So we're not looking at the perfect answer anymore. We're trying to solve problems that might have multiple solutions. So just keeping in mind the digital competency framework.
Another reason, so why code? I see there's a lot of ESL teachers, language teachers. So it's good for all subject areas. It's not just applicable to math, science, and technology. The students we teach to nowadays are born in that 21st century, which is the digital age. And the goal of education is to prepare students for the future. And when I say that, I'm thinking of all the jobs that are out there, to prepare them for jobs that we don't even know will exist later on. And when we think of the digital age, we think of the whole world that's been turned upside down by software, by robots, by automation, just in agriculture, marketing, financial analysis, even arts and communication. So our students, they're born into this world, and we know that not all of them will become programmers or software engineers. But it's important for them to get to understand code, to be able to understand the works of it, and maybe even to read it. Some will, though, become software engineers and coders and programmers. And the truth is that, let's say we're thinking of back in 2013, when online banking started and online communication started, none of us knew how to read code or understand it. But nowadays, we depend on all that technology. And more people are learning, which is why it's important to teach it to our students. And I guarantee that when you know the basics of coding and programming, you will see the world differently. For example, your phones. It's just a piece of technology, but when you understand the basics of coding, you'll understand why on the specific press of a button, your phone does X thing. However, it goes beyond the workforce. So we're working towards developing computational thinking with our students. So yes, work and employment will be important later on, but even more important than that is developing computational thinking. It sounds like a really big, overwhelming, scary word. And at first, I too was intimidated by it when I started working as a RÉCIT consultant. However, let's break it down into pieces and actually use computational thinking to understand it. So computational thinking is the process of thinking through a problem step by step in a measured and logical manner. So it's kind of like making a lasagna. You're looking at your ingredients, you're seeing how to create it. So your first layer, and then you recognize that there's a pattern. So you can repeat that same pattern, you're abstracting that pattern. And in the end, you come up with a recipe, which is your algorithm. And during that whole process, you might be tinkering, getting creative with that lasagna, adding some cheese or pepperoni or salami, maybe some spinach, cottage cheese. You might be debugging. You didn't buy lasagna noodles, you bought cannellonis. So let's turn it into cannellonis for supper. And you'll be persevering and collaborating. So computational thinking is really everywhere in our daily lives. It's not just in programming. It's also, for example, when you're creating a book report or solving math problems.
So that brings us to the next part, and I wanted to include these two. When you access the slideshow, you can access this video and also the link. Both are by Mitch Resnick, who's one of the creators of Scratch, and the way he talks about not just learning to code, but using code as a tool to learn. And I've used a lot of coding tools in my classrooms, and I've seen how it provides an opportunity for us as teachers to really see how our students are thinking. So it's really a great way to get that thinking kind of visible. Next slide.
Oops, right.
Just skip that. And then what's really what's kind of interesting as well is the connection between coding and language. And so when I talk about it with students, I say, well, coding is a language. It's the way that we communicate with computers and machines. And if we break it down like this, we can see there's different levels to coding. And so one of the easiest entry points is using block coding, like in Scratch. And in the resources on the previous slide, Resnick talks a couple times about, he kind of makes a parallel between coding and writing. And so in schools, we often teach how to write, even though not all of our students are going to become professional writers. And we still teach how to read and write because they're important skills to be able to learn. And so coding is kind of similar in that. We're not expecting all of our students to become computer programmers, but by teaching coding as a tool, just like we teach reading and writing, we can have another way for students to learn those competencies that Carolyn showed earlier for computational thinking, like problem solving, creativity, and so on.
So I'm not going to present the environments right away because we're going to be doing that during the code along in a few minutes. However, I just wanted to describe the differences between both so you know where to go. And by the way, we do a lot of Scratch Junior and Scratch. It's a great way to start programming with your students because it's very low floor, wide walls, and high ceiling. And maybe you've heard the expression before, low floor, high ceiling. So low floor, it's a great entry point for students to start scratching. It's really at a great beginning level for all students. High ceiling means that for those who love a challenge, you could take it very high. Students can create very sophisticated projects like games and whatnot. Wide walls, so low floor, high ceiling was Seymour Papert, and then Mitch Resnick from Scratch added wide walls, which means there's a diversity of students in front of you in the classroom. So how can we address this diversity? And it's by creating projects that offer all of these possibilities for students. Like Lexi said, there's not just one good way of doing something. Students can create different projects depending on their passions, interests, and their learning, and still make an amazing project that follows your guidelines and evaluation. Scratch Junior, so this is the Scratch Junior interface. As we mentioned, it's block programming. It's kind of like little puzzle pieces. It's really for the younger ages. I'm thinking preschool, maybe, and cycle 1. ESL teachers, if ever you have young students, it could be with Scratch Junior as well. So depending on the students you have, it's a very low floor, and you can also start off with the younger ages with Scratch Junior, then quickly move on to Scratch. Here's the interface for Scratch, so it's quite similar. For those in languages, this is a fun one where it's programmed, so when you click on the food, it says the word. So it writes it out and it pronounces it for the student. Scratch Junior can be used, for example, elementary cycle 2, 3, high school, adult education as well. So, does anyone know Scaredy Squirrel? Scaredy Squirrel wants to try a lot in life, but he's very scared and overwhelmed, and everything is really intimidating. Now, Scaredy Squirrel understands the benefits of coding in the classroom. However, Scaredy Squirrel doesn't know how to code. So he gets to the classroom, he followed this training, he's all equipped, and he's ready. However, he's still scared because children will ask questions, and he's not sure he'll know the answer. He thinks maybe, and most probably, sometimes the programs won't work, which is normal. He's afraid he won't be able to manage bugs, so how to debug a problem when it occurs. And he's afraid that the students will find out. They're going to find out that Scaredy Squirrel doesn't really know how to program. And this is great because you don't have to be an expert at programming Scratch. Don't wait to integrate it in your classroom until you feel like you know it all. Your students will fly with it. They'll become much better than you. So it's okay if they find out that you're not an expert programmer. However, in all squirrel fashion, remember that if all else fails, playing dead is a good option. Just play dead.